Hello and welcome to Mr. Davis's Algebra 1 class. Today we're going over lesson 6.4, which is applications of linear systems. This is your warm-up, so please pause and do the warm-up before you move forward. Now, when we talk about applications of linear systems, basically what we're talking about is word problems. So this should be a favorite of most people. Now let's go to our first slide. Now, when we talk about applications, we really can choose what type of method we're going to use to solve these problems. Now, we've learned three so far, which is graphing, substitution, and elimination. Graphing, we might want to use when we want to display solutions or get an easy estimate of a solution. Substitution, maybe when one variable is already solved. And elimination, when we see the coefficients of the variables are opposites of each other or close to that. Now, we're going to be doing three different types of problems today. Each one kind of gets set up a little bit different. Well, first problem is called a break-even point. And when we talk about business, a break-even point is when, as a business, you have not made nor have you lost money. So this is where your expenses and your profits are the same. So we're going to make two equations. Each one of these, we should be making two equations. So we're going to make two. One's going to be called the expense equation. One's going to be the profit. So let's start with the expense one. So the money, Y, expenses, maybe we'll write that up here. So Y is going to be our money, X can be our, what we sell, hats, right? Hats. So the money, for as far as expense goes, is going to be equal to, let's see, which one of these is expense ones? The material for each has costs $5.50. So cost is $5.50, and that's $5.50 per hat. So since we can say $5.50 per hat, we know it's going to be $5.50x. The hats sell for $12.50. Now that's also a number, but it does, when I sell them, that's not an expense. That's not an expense, so I'm not going to use that one in my expense equation. And it says the designer spends $1,400 on advertising. Now, spends, again, is an expense, but I cannot say $1,400 per hat. That's just a lump sum of $1,400. So that's going to be a lump sum. There's no per hat on that one, so it's not going to be with the X. And those are the only figures they give us, so we're done with our expense equation. For profit, again, my money is going to be equal to, let's see, I think the only one that we didn't use was that $12.50. And that's how much we're selling it for, right? And that's $12.50 per hat. And there's no lump sum part to the profit. Now I have these two equations, and I can choose which way I want to solve them. I could choose substitution or elimination. I probably would not choose graphing because if I don't want to estimate the answer, I want to know what the answer actually is. So I'm thinking since both these equations are already solved for Y, I'm just going to use substitution. Okay? So what I'm going to do is I'm going to drop down this equation. Notice I didn't write Y, I left Y out. And I'm going to plug in what Y is equal to. Okay? Now, one variable, let's solve. All right? So I'm going to get all my x's to one side. So I'm going to subtract 5.5x. Subtract 5.5x. That gives me 7x is equal to 1,400. Divide by 7 on each side, we get x is 200. So x stood for hats. So that tells me I need to sell 200 hats to break even. If I sell less than 200 hats, I lose money. If I sell more than 200 hats, I make money. So that's a break-even type of problem, which you guys will be doing on your first group of problems. Here's got it number 1. Go ahead and pause and do this one. Refer to the previous problem in your notes to help you through it. Problem number 2 is a mixing problem. Okay, and we have a dairy owner who wants to make, or actually has 1% fat and whole milk, and he wants to combine them to make 100 gallons of 2% fat. Okay, so on this one, let's come up with our variables first. I'll say x will be, because I don't know, I need to know how much 1%. So x is going to be in my gallons of 1%. Y will be my gallons of 3.5%. And I'm going to mix those together, and my product should be 100 gallons of 2% fat. Well, first off, on these mixing problems, should have 2 equations. The first one's pretty easy. I'm just going to say, hey, when I mix my gallons of 1% and my gallons of 3.5%, I should get 100 gallons. So that's kind of like the total, the sum of everything that's being added together. So that's the easy one. The next one is we're dealing with percents. And when we deal with percents, we have to do both the percent with the total amount of gallons. So 1%, so I'm going to say 0.01, that's 1% in decimal form, times x. 0.01 times x, I'm going to mix that with 0.035 times y, and that's going to equal 0.02 times 100. Now, right here, I'm going to pause. Okay. Now, let's see what we have. We have a percent and a gallons. That's our percent and our gallons. And at the end, I have the percent and the gallons. So we set it up where we have the percent times the gallons on each piece. On the left-hand side, we have the 2 things we're mixing. On the right-hand side, we have what we're mixing it to equal. Okay. Now we have all of this. We need to decide how we want to solve it. Well, I think I want to solve it through elimination. And what I think I noticed is if I take this blue equation on the right and I multiply it by a negative 100, a negative 100 will give me, right here, a negative 1x, thus eliminating with this x. So let's do that. I'm going to take this whole side and multiply by negative 100. So again, negative 100 times 0.01x can be negative x. And negative 100 times 0.035y is going to give me a negative 3.5y. And then, let's see, we'll do this in parts. 0.02 times 100 is going to be 2 times negative 100 is going to be negative 200. Now, basically what we've done here is we've taken, by timesing by that negative 100, we've just made them the opposites of the percent, right? Negative 1, it was supposed to be 1%. That's the middle number, the y is a 3.5%. All right, so when we add these together, the x's eliminate. I get negative 2.5 y and negative 100 after the equal sign. I want to divide by negative 2.5. Y is equal to a positive 40. If I look, that's a positive 40. Y was gallons of 3.5%. So if I have 40 gallons of 3.5%. That must mean, since I have 100 gallons total, 60 gallons of 1%. And that's how you do a mixing problem. Okay. And on mixing problems, it doesn't matter if you're mixing milk or antifreeze or acids, they go the same way, right? You're gonna set them up that same way. So here's one for you to try where we're mixing antifreeze. All right? So mixing antifreeze, if you need help, refer to that previous problem or your notes. All right, last problem for the day is talking about traveling in an airplane, which when you're traveling in an airplane, a lot of times you have wind as a factor. Here we're flying from Los Angeles to Charlotte, and somebody's flying back from Charlotte to Los Angeles. So we have ground speed and airspeed for each one. What the ground speed means, what ground speed is doing is how fast the airplane is actually going. The airspeed is how fast the plane would be going if there was no wind. All right. So on these ones, what we want to think about as plane 1 being an equation and plane 2 is being an equation. Okay? So this is how fast I'm actually going. So that's kind of my total, right? A lot of times I'll tell you guys to look for the total. So that's my total. That total is made by my airspeed, A, but since I'm going with the wind, the wind is adding to my speed. On the other one here, okay, again, my ground speed is my total. And then I can think of my airspeed. And then I'm going against the wind, so it's going to be subtract W. Okay? So basically the same exact question, only difference is one's a plus and one's a minus. Well, since I see they're pretty much the same, but one's a plus, one's a minus, I think I'm going to use elimination. I'm going to take this red equation, and I'm going to drop it down below. And I'm going to try to eliminate the W's. So when I add them together, I get A plus A is 2A, W plus a negative W, that eliminates. And last, I get 550 plus 495, which is going to be, what, 1,045. Divide by 2, I get A is, what is that going to be, 522.5 miles per hour. Okay, it's 522.5 miles per hour. Well, let's see what they were asking for. Were they asking for airspeed? What's the airspeed? Okay, so we got that. What's the airspeed? They went 522.5 miles per hour. But then they also ask what's the ground or the wind speed. So let's go back down here. I'm going to drop down one of my equations. I'll go ahead and use this blue one right here. So I have A, which I know is 522.5 plus W, which is still unknown, is equal to 550. Subtract 522.5, subtract 522.5. I get W is equal to, what is that going to be, 27.5 miles per hour? So my wind speed is 27.5 miles per hour. And that's how you do a problem like that. Now this could be with wind speed. You might see it as a boat with a current, right? But both those will affect speed. All right, here's one again with a boat. Good luck on that one. And here's your guys' homework assignment. As a reminder, we do have a mid-chapter quiz coming up next.